In this step, we'll learn how to compile and train a model. What we earlier did was we defined the graph of the neural network. You had a couple of layers. And what we need to do is we need to compile this graph before we start the training. So let's get started. So I would say model.compile, and I have to feed three features here. The first feature is the categorical cross entropy. This is an implicitly defined feature that you can use. Here what you do is you define what's the loss function that I need to use. So categorical means we do a classification. So the loss function is associated with the group over category. So we can use the categorical cross entropy. The other function is the optimizer. The optimizer says how do we need to optimize the gradient descent that is used inside the training process. So here the optimization uses adder. There are other optimizations like adder. You can research and you can read the lecture notes, and you can see there are many other optimizations that can be used to optimize the gradient descent that is used in deep neural network training. The next value is the metric. This is very important. Here we are doing a classification. So obviously we need to know how accurate our model is. So you can say the parameter is accuracy. These are inbuilt features from TensorFlow and within Keras as well. So you just need to mention the necessary attribute and you can just compile the model. So here we also have a benchmark for compiling, and the other step is training. So here what happens is we already have compiled the model, and we need to say training values and corresponding labels, number of epochs. How many times are we going through this dataset while training? In iterative models like deep neural networks, K-means or SVM, like machine learning algorithms, we need to go through the data a couple of times to teach this model to the trained model to understand how each data point is related to a given category. That's how it learns. It's a complex process. In this tutorial, we just use 2 epochs, but you can use different size of epochs, different number of hidden layers, batch sizes to train the model. So you can see the training has been completed. As you can see here, the initial loss was 0.3486 in the first epoch. By the end of the first epoch, by the end of the second epoch, it is 0.3052, and we can see when the number of epochs increases, this loss may reduce, while the accuracy will be also increasing. In the next step, what we are doing is testing. So we have a trained model. Let's test it. So in testing, what we do is we say model.evaluate and we pass the test data. This is the test data images and the corresponding labels. And we say the batch size, which is number 4. You can specify any number here. So this will be just evaluating the model. And then it prints the accuracy. So it says 91.7%. It's not too bad, but it's not the best. So you can get an accuracy around 98 to 99% if you create a decent model. So you can optimize this by changing the batch size, changing the number of epochs, changing the number of batch size, number of hidden units, likewise. You can also add more layers, but we will discuss this one in a different tutorial. Finally, let's call the benchmark. Here it gives all the details about the system where you initiate the testing, and it gives all the time breakdown for data loading, compiling, training, and testing. As you can see, it states the date and time when you ran the experiment. So this is a very useful benchmark suite provided by CloudMesh. So we recommend you to use these toolkits to design your projects, to design your homeworks. These are some references that will be important to learn more information about this. The Advanced Deep Learning Models, it's a very important book and a very important place where you can learn lots of information. And there are many examples written by different people on classifying MNIST. This has been a very famous problem. Everyone starts with this problem. So in this class, you also start with this problem. And in the next stages, let's see how we can use different techniques in deep neural network to improve our training process and get a better accuracy.